Good morning, everyone. We've got about 5 minutes, and then we'll get going with Dr. Lindline. And good morning, everyone. Welcome to today's HU Talks. I'm your host, Paul Grindstaff. Our presenter this morning is Dr. Jennifer Lindline. And well, first of all, thanks to the almost 30 people already on here. We've had great attendance for every single talk, and every talk has had real staying power. Usually the number of attendees grows as we go along. To introduce our speaker to you, Dr. Lindline is a professor of geology here at Highlands. And if you haven't had a chance to look at her bio on the nmhu.edu website, you really should. Aside from a lot of really impressive geology terms and research background, you'll see that she really focuses on things going on close to highlands and around New Mexico. Studies on Hermits Peak and of course the volcanic history of northern New Mexico, and that's no small task for someone that went to undergrad, graduate school, and received their PhD in Philadelphia. So we're lucky to have had Dr. Lindline here for the last 20 years. She has in the past established the Natural Resources Management Department as well as the Environmental Geology and Forestry degree programs. She works really diligently to create opportunities for student learning and discovery. Of course, being in geology, there's a lot of hands-on stuff, instrument uses, research mentorships, and agency internships. She enjoys sharing her love for the environment, and if you want to know just how much she does, ask any of her students and they'll tell you the same. This morning, we're privileged to listen to Dr. Lindline talk to us about something that's gone on recently, and the title of her presentation is Water After Wildfires, 2 years post the 2022 Hermits Peak Calf Canyon fire. And with that, I'll yield the floor to our presenter, Dr. Lindline. Jennifer, welcome. And
Thank
we'll
Thank you so much for that great introduction, and thank you for the opportunity to present about something that I am working within and something that I am passionate about. It's my pleasure to be here. And it's definitely uplifting to see so many familiar faces. Thanks, guys. But for those who don't know who I am, Jennifer Lindline, as Paul announced, I'm a mom, I'm a wife, my family is very important to me, and so is my Highlands family. I've been teaching at New Mexico Highlands University since January of 2000. This actually is my 25th year. I'm a cowboy at heart. The Santa Fe National Forest, the mountains all around Las Vegas, New Mexico, are my special place. It's a place where I raised my family. It's a place where we've celebrated birthdays and enjoyed various milestones and embedded my daughters in nature, their surroundings. It's also a place that we can use as a natural laboratory to enhance our geology studies. Students have been involved in mapping Hermits Peak and its surroundings and understanding its history. It's almost 2 billion year history from its formation, deformation, and reconfiguration over time. Getting to the top of those mountains is a big feat, whether it's one of us, a few of us, or several classes of us. So it's something that we celebrate. The Guyanus watershed as well. Like Paul said, coming from Philadelphia and being a hard rock geologist, I'm transitioning into environmental issues wasn't an easy one, but it was one that I took with happily, because it's something that the students were interested in and something that the students wanted. So from early on, students wanted to study things about the quality of water in the Guyanus watershed, the watershed that supplies so much in terms of ecosystem services to all of us who live and enjoy these mountains and these landscapes. That all changed after the summer of 2022. The Hermits Peak Calf Canyon fire was the largest and most destructive forest fire in New Mexico's history. It transformed the biotic and the socio-cultural environment of northern New Mexico and its watersheds, whose services are so critical to lives and livelihoods. Here's a picture of the outline of the Hermits Peak Calf Canyon fire footprint over a map that the New Mexico Forest and Watershed Institute prepared of the major watersheds of New Mexico. The Hermits Peak Calf Canyon fire affected several watersheds, including the Upper Rio Grande, the Upper Canadian, and the Upper Pecos. And the burn severity ranged from very low, moderate, to high. We see this very diverse burn mosaic. And those burn severities are important because they tell us if and how much the soil structure was impacted by the fire. The lower the burn severity, the more of the natural leaf litter or remains intact, and the more of the soil structure, its soil porosity and water absorption ability maintains. The higher the burn severity, the less so. The soil porosity is diminished and the water absorption and water retention ability is diminished. And we have fire sedimentation events, hillside erosion events, floods, and landslides. And these effects are, there's things that we as a community have been living with for more than 2 years. So in focusing today on the Guyanus watershed, as outlined here in another map that was created by the New Mexico Forest and Watershed Restoration Institute, we see that the Guyanus watershed is several tens of miles in length. It's the upper Guyanus River. It starts in the Sangre de Cristo Mountains at an elevation upwards of 11,000 feet and changes 3,000 or 4,000 feet in elevation as it moves downwards. I like this outline of the Guyanus watershed. My colleague, Dr. Fouché, always says that it's funny to her because Guyanus, I guess, means chicken in Spanish, and she thinks that outline looks like a drumstick. Appropriate. The Guyanus watershed has many uses. It's a subwatershed of the Pecos watershed. It includes forest, rangeland, farmland, and dispersed residential development. It has sustained the more than 500-year traditional Hispanic acequia systems. It's designated as a high-quality cold water fisheries. It has many rich and diverse ecological values, and it supports the rich farming, ranching, and other long-standing uses, all of which depend on a clean and continuous supply of water. Today, I'll mostly be focusing on if and how the Guyanus River has maintained its various chemical and physical parameters for a cold water aquatic life, and also the impacts of the fire on our public water supplies. We know that over the past 3 summers, our community has been in a water crisis. The fire sedimentation and the debris has just tainted our water supplies and made it difficult for, just has put those stresses on our drinking water systems. In 2023, the Rio Guyanus was designated as one of America's most endangered rivers. So like I said, I'll be talking a bit about water quality and also water quantity. Water quality is the measure of the health of a stream. It provides knowledge to people who depend on the river for its ecosystem services and empirical evidence to water managers, decision makers, restoration specialists, and others about environmental issues. My students and I have been regularly collecting physical and chemical information on stretches of the Pecos River, and we've also been analyzing data on such on the Guyanus River. And all of these help us to better understand its health. We're looking at amounts, we're looking at trends, and we're looking at these features in terms of the relationship to activities. We're also looking at the amount of stream flow, water quantity analyses, looking at the amount of water that's moving through the system. What are its trends, its highs and its lows, and how do those statistics vary? In terms of the Guyanus, we've been relying on this thing here. This is a gauging station that was developed by the U.S. Geological Survey. It is one of the longest standing gauging systems in the USGS's real-time surface water collection systems. The oldest gauging system is at the Embudo Station in Taos, but the Guyanus is one of the oldest. It's been in place since 1926. We've got nearly 100-year record of data that helps us understand system variabilities for stream flow. It only was equipped with the ability to measure these various parameters here: temperature, dissolved oxygen, pH, specific conductance, and turbidity after the Hermits Calf Canyon fire. I think those data became available starting at the end of August or early September 2022. I'll be presenting to you guys a number of graphs that I've pulled off of the USGS's real-time surface water database and develop those graphs and how they relate to the services of the river. On all of these graphs, we've got the gauging station titled at the top. We've got the parameter that we're measuring on the y-axis on the left, and the data that are presented are for over the past 2 years, from September 1st of 2022 all the way through August 31st of 2024. So 2 years of data. You'll notice on some of the graphs, there are breaks in the data. For all the graphs, the blue are the actual data points or the data that are measured. And where you see gaps, that's where the instrument stopped for one reason or another. In many cases, it's because it iced over, as you can kind of see here in the winter months. And then there's some other reasons why at times the instrument just stopped collecting data. But we have it for the most critical months, the summer months. The graphs also show us some statistical information. For the green, it's the period of approved data. And then we see the most recent data for the most recent months. It's called provisional data. The USGS hasn't completely released it for scientific use. It's just for general use. Okay, so let's look at temperature. When we're looking at temperature, we see that over the course of the past 2 years, the upper Guyanus River's temperature has ranged from 0 to 26 degrees Celsius. The threshold, according to the New Mexico Administrative Code, for maintaining high quality cold water standards is between 20 and 23 degrees. So I put this line on here. We see that in order for the river to maintain its high quality standard or its high quality designation, its temperature should remain below 20 degrees or no higher than 23 degrees for more than 4 hours. And yet during the summer months, we do see many days in exceedance of that threshold. And so that's telling us that the system has been impacted and it threatens that designation. This graph is showing us pH. pH is a measure of the acidity of the water or the number of hydrogen ions relative to hydroxyl ions. If you've got a value less than 7, the water is acidic. If you've got values over 7, it's telling you the water is basic. For high quality cold waters, the range of accepted values is between 6.6 and 9 for pH. And the Guyanus River has maintained that for the majority of the 2 years study. It's only had exceedance a handful of days. The range of pH is between 7.4 and 9, and it reflects the geology that the water moves over or through. So the rocks are relatively basic, and it produces these basic waters, or these waters with pHs between 7.4 and 9. Another parameter that's important for water systems is dissolved oxygen. It's just a measure of how much oxygen is dissolved and how much water is available to aquatic organisms. For high quality cold water systems, the amount of dissolved oxygen should be at 6 milligrams per liter or above, where I put that red line in there. For the Guyanus, its range over the last 2 years has been between 6.5 and 12 milligrams per liter or parts per billion. So in terms of that parameter, the Guyanus has maintained its threshold. It's within the New Mexico Administrative Code's standard. Then we have specific conductance. Specific conductance describes a water's ability to carry an electrical charge. It's an indirect measure of the amount of chemicals that are dissolved in a water body. The collection of specific conductance data has varied, but for the data that are there, we see that the values for the most part range between 125 and 310 microsiemens per centimeter. And those values are within the high quality cold water threshold, below 300 microsiemens per centimeter. But here we have turbidity. Turbidity is a measure of the clarity of water, or how much, how clear it is, or the opposite of that is just how turbid it is. So these are the turbidity data from, over the last 2 years. Turbidity is so important for the aquatic organisms that depend on clear waters for reproduction and for life, and just for our drinking water systems and able to treat those waters. We see here that the New Mexico Administrative Code states that turbidity values shall not exceed 10 NTUs. NTUs is the unit, nephelometric turbidity units. It's the measuring unit over background. Let me ask you guys, forget these lines that I drew there for a minute. What would you say the background turbidity for the Guyanus is, given the data that you see? Not any of these punctuated events, but just the background. Who wants to take a stab at that? Kristen's thinking the background's 500. Anybody else? On most given days over the years, pre-fire, when my students and I have studied the river, or folks from the Hermits Peak Watershed Alliance have studied the river, the turbidity values are often less than 10. Let me see what else it said in the chat there. Nathan's thinking 85. On a given day, the background's usually actually less than 10. And after the fire, speaking to Maria Galvares, the director of the former director of the water treatment plant, she had said that the water treatment plant has to shut off if NTU values are greater than 40. That's where I put that line in there, that 40 for the city's water treatment plant pre-fire. I put that line in there for 500 because I know with my colleagues with the city of Santa Fe, their state-of-the-art water treatment plant at the Buckman Direct Diversion System, they shut off at 500. So now when you see these values here, post-fire, not only has the Upper Guyanus River had many days in exceedance, many days above 10, many days above 40, many days over 500. We're still trying to work out the statistics to say exactly the percentage of days it's above those various thresholds, but we know that it is. And this was a picture that I took out in the field with Nathan just a few weeks ago, standing at the High Point overlook, looking down at the river right before it hits the city's diversion. And we see that brown ribbon. Over the years, anytime I took this picture, the Guyanus wouldn't have been brown. It would have been clear and just clear and see-through. But that brownness, that turbidity is just an after effect of the fire. This picture too shows the canyon sides and the spottiness of the fire or the burned areas that with each rainfall, with each snow melt, the ash and debris that runs off into the river. So before I keep talking a little bit more about water quality, I wanted to talk about water quantity as well. So I said earlier that we have almost a 100-year database of stream flows for the Guyanus River. That's an incredible database to have. Well, it's an incredible number of data points to download and manage and statistically treat. But it's important to have those data because it shares with us just what the stream's variability is in any given year. So let's walk through this together so we can understand what this graph is showing us. So this graph plots 96 or 98 years of record for Guyanus stream flow. And the dark line, it's showing us from January 1st to December 31st for all of the years on record. The areas that are in the dark blue are showing you all the range of values that occur between the 25th and 75th percentile. The lower the values and the higher the values, we're getting into the 10th and the 90th percentile. And then when we get to the lightest shades, we're seeing the minimum and the maximum flows that have been recorded on the Guyanus River historically. Flows are given in cubic feet per second. Post-fire 2022 data are plotted here in red. One of the things that we see in a lot of systems is post-fire, we get a lot more runoff, higher volume of runoff. That is just something that's seen in systems all throughout the Rocky Mountain West. It's hard for us to say if the flows that we're seeing are a result of the fires because we don't have any pre-data at that, to relate for those same precipitation events for the same hydrological response. But what we do know is that during 2022, just about the time of the fire in mid-June, we were at a very, very near extreme minimum of flows. And then the river started to flow high. And we recall all of those, we recall those floods in the summer of 2022 and those exacerbated events, those punctuated events throughout the fall until the monsoon season and the precipitation events waned. I've also put on here 2023. 2023 was also within the range of variability of the Guyanus system. Recall during the summer of 2022, we actually had very low flows throughout June and July until the rains came, and then the system started with these high events. There weren't any floods during the summer of 2023, but we did have these punctuated events until precipitation waned. And then came the summer of 2024, this last summer. We see that we see all three seasons, 2, 3, and 4, the snow melt runoff was within the range of variability, that the Guyanus typically shows. But when we get to the summer, we start to see these punctuated events, see these real flashy events, and the floods that the community experienced. And with these floods came these high volume turbidity events as well. And those turbidity events put the system in crisis. This is a picture that I took from a news reporting back in the summer of 2022. And it was just reporting ABC News on ongoing water crises throughout the United States. So our little Las Vegas was up there with places like Baltimore, Maryland, and Houston, Texas, and Benton Harbor, Michigan, in terms of water crises. Most of those other places had to do with aging infrastructure and problems with their systems. And I guess you could say too, ours has to do with an aging infrastructure, one that wasn't able to treat the high volume runoffs and those high turbidity events that came with the post fires. So here's a map of that I created using Google imagery that kind of gives us a framework of the city's water delivery system. The Guyanus is here kind of coursing along this line. And we've got the city diversion shown here towards the west or towards the left-hand side of the diagram. Up here, the road that's coursing through here is US 65 or State Road 65. And that's High Point Overlook from where I took that picture a few slides ago. The city diverts the Guyanus River and channels it over to the sediment basin where where sediment can settle and the water clarify. After which they pump it through a series of pipes over to the Peterson and the Bradner reservoirs for temporary storage, and then over to the water treatment plant for delivery to the community of Las Vegas. You can see in this image, our forested watershed, and then that stark contrast with the Eastern Plains. Here's that same picture or Google imagery just from a few months ago. What do you see that's so different from the previous image to this image? Anybody can chime in.
I think you can kind of see the fire scar. You can
Thank
see,
you.
yeah, the mountain's not as green.
The mountains are definitely not as green. You can see the fire scar. You can see the patchiness to it as well. It wasn't a complete fire scar, but you can see it's almost a mosaic of burns and burn intensities. But with that mosaic, it's on both sides of the Guyanus River. So both sides, experience that fire sedimentation, the debris, the ash, the charred organic matter getting into our system. A sediment basin that was never built to clarify that kind of debris in a system that the water treatment plant that just can't treat those high turbidity values. And such, with those high monsoonal rain flow events, they bring those high turbidity events and put our system into a emergency or a water crisis. All of you guys were part of having to pick up bottled water. Everybody was part of being on those restrictions and not being able to launder clothes or time showers and just other kind of businesses or daily activities that were severely restricted, and the angst and the anguish that it caused. But in looking at articles preparing for this talk, or I'm talking with my students as they prepare their literature reviews or their understanding of the system, our city has not been in the situation that is in just because of the fire or just post 2022. Looking back, here's a quote from former Mayor Tony Marquez, talking about our regional drinking water supply shortages present the most immediate threat to the region's economic stability and quality of life. I found similar articles in 2012, 2014, and even ones going back myself, going back to the 90s and the 80s. Thinking to that graph that showed stream flow variabilities, there are times when we have very high flows on the river, thick snowpacks and big snowmelt runoff events. But there's also years that we're in drought. There are years where businesses were in restrictions and the community was forced to drink bottled water, having nothing to do with the fire, but just because of water shortages. So the system has long been in stress. But one of the things that the fire has done is hold our community together ever much more so. If you ever found a community that was resilient, if you ever found a community where that word unity could be bolded and highlighted or enlarged, it is the city of Las Vegas. Because anytime there is a crisis, folks come together. There's no complaining. People just roll up their sleeves and people just get the job done, including folks that work in water resources services. In 2022, when I gave this talk and talked about the status of the situation, I shared some old and even some new ideas to how to kind of get the situation out of crisis. And last year, I presented to you how the city had a 4-point plan in moving forward, in trying to maximize its resources and build some adaptation strategies. And I'm happy to say today, the path forward, some of these have actually been checked off. There are so many conservation initiatives in place with lowering the demand on the system and improving what is there. The monies that have come, the federal monies that have come with the HPCC fire, have given the city the ability to not only improve or expand and upgrade its water treatment facility, it's now able to improve a lot of its infrastructure. So instead of just, I think a little bit about President Wolf getting these HU talks kicked off on Monday morning and speaking how he lives his life with baseball analogies. And there was another writer for the Las Vegas Optic that was talking a little bit about baseball analogies in this situation. Instead of putting all of our money into that one star player, the water treatment plant, the city is now using that money to shore up its bench or shore up the whole team and improve the infrastructure. So we're getting that new water treatment plant, but they're also looking at the leaky pipelines and different places in the dam or the whole system to lessen the chance that any of these crises happen again. One of the things I did want to say too, though, was that the city depends more than 90% on surface water, the Guyanus water, for its drinking water supply. Any system that depends that highly on one water resource is a system that's vulnerable. All the water treatment plants in the world aren't going to do any good if we're in a low flow year or our reservoirs are at a low storage capacity. So how do we expand and enhance our water resources to be more resilient to any of these threats, not just fire sedimentation, but also water quantity or water amounts? We need a skilled workforce, and we need geologists out there to be part of the calculus. And so I share this map with you and this book with you because it's something that I remain very proud of. My geology faculty team, Joe Zabrowski and Mike Petronis and I, were part of a group that put on a conference in 2015 where we brought more than 300 geologists to the Las Vegas region to study the geology and focus an entire day on its water systems and water delivery. There were so many ideas that were bounced around on that day, so many challenges that were recognized. And one thing is clear, we do know the geology. We do know it's Proterozoic rocks from its Paleozoic, Mesozoic, and all the rocks that go into the Las Vegas Basin. And unless you add groundwater storage, some kind of managed aquifer recovery into the calculus, then we'll remain vulnerable. So something that I pitch and something that is possible is having some kind of storage and recovery, using some of the geology out here to the east to maybe take some of that water from the water treatment plant and directly or indirectly filter it back into the aquifer or reuse it using our water rights and our full consumptive allotment to enhance and expand on the city of Las Vegas's water systems. And so the skilled workforce part, that's also where we come in. The New Mexico Highlands University Environmental Geology program teaches a number of degrees, a number of minors, and offers a number of certificates that builds that workforce and provides that geologic knowledge and that technical expertise to go work for the New Mexico Environment Department, the Office of the State Engineer, and to work at our new and expanded water treatment facility, including we've got a water resource science certificate program in progress that we hope to have delivered by the end of this academic year to assist with those water treatment operations and systems. We're often getting grants to, again, build that pipeline of students to be able to work in these fields, but also to to collect the data, manage the data, and interpret the data to inform these decisions. And again, career preparation. We've got equipment, benchtop chemistry equipment, a number of geographic information systems, and remote sensing and LiDAR capturing capacities to help collect those data and inform the process. And we build partnerships with our Upper Pecos Watershed Association, the Hermits Peak Watershed Alliance, the New Mexico Forest and Watershed Restoration Institute, the USGS, the New Mexico Environment Department, and more are various partners that we work with on student projects, or they themselves take on some of our interns to go from summer experience to semester experiences to job entry pathways. So to end, I'm very happy to be part of this conversation. I'm really, really happy to have had the opportunity to speak with you guys and to just emphasize that the community of Las Vegas deserves a clean and continuous water supply. Every day, the system is recovering, the community is growing more resilient, and we're getting there, but it takes a village, and I appreciate you being here, and I appreciate your continued support. Thank you.
What a presentation and what a resource you are, Doctor. Did everyone see the opportunities for students and how robust our program is in geology? That's pretty remarkable. And of course, when you have real world application like this, it expands the opportunities. And I think that's one reason. And of course, it's a local impact. That's why we had so many participants. This is about twice as well attended as some of the others. Dr. Lindline, well done. Thank you. Are there any questions for Jennifer?
I've got one. For some reason, I got focused on the sediment catchment. And is it designed to be cleaned out? I assume it is. And how often is it cleaned out pre and post fire?
Thank you, Adam. I'm not sure exactly how often it is cleaned out. Right after the fire, the Army Corps of Engineers came in and was putting different sediment catchments even above that city diversion and doing everything they could with gabions and different kind of rock and cage and catchment structures to prevent all that sediment getting into that basin, but it just was overflowing the system. And during the time of crisis, the Army Corps of Engineers was pulling it out. But once that emergency was over, those guys kind of left. And I don't think the city of Las Vegas had that capacity to clean it out as often as it needed.
Thanks. One more question while I'm at it. You're talking about ways of collecting or accumulating more water for the city of Las Vegas, and your idea was pitching and diverting some more water to the east of town. Back in my day at Highland, the idea of floating around of was it snow catchment, finding ways to catch more snow in the mountains to have it already reserved and melt slowly down. Is that still an idea, or is that? Yeah, I'm all ears.
Thank you, Adam. I don't know about snow catchment, but definitely there are conversations about catching and storing some of our existing water so that, or yeah, our water rights so that we can use or reuse it into our supplies.
Thanks again.
Time for a couple more questions. Well, Dr. Lindline, if folks have any follow-up or they want to reach out with how they can learn more about your work or what's going on, what's the best way for them to get a hold of you?
Anybody can email me anytime. It's my last name, first initial, lindlinej@nmhu.edu.
And there we go. Lots of compliments in the chat box. Everyone, just such a well-received presentation. So thanks, Dr. Lindline, and thanks to all of our attendees, north of 50 the entire time. We started out almost 30. And anything you can measure, we can improve. And boy, 50 at 9 a.m. on a Wednesday, that's remarkable. So thank you so much.